next objective that we want to focus on in this lesson is how do we write a quadratic that is in the form ax squared plus bx plus c in vertex form. So for instance, here's an example here of a quadratic function. But if I just look at that quadratic function, we're not able to identify the vertex based off of, say, the way we were able to identify the vertex over here. Because in this example here that I made up, we looked at how far right the graph went and how far up or down the graph went. Excuse me, not right, but how far left the graph went and how far up or down the graph went to be able to turn that into our vertex. But that's because this is written in vertex form. This here is not written in vertex form. This here is written in standard form. So now we're going to talk about how do we change that to vertex form. Well, there's a process of steps that we'll follow that are outlined here on the left for us. I'm going to do the first step, which says to factor out the leading coefficient. The leading coefficient is just another way of saying a. There's our a of 2. It's our leading coefficient of the x squared term from the factor out the leading coefficient of the x squared term, which is just a, from the two terms containing x. So what we're going to do to get started is we're going to factor out 2, but we're only factoring it out from the two terms that contain x. So we are not factoring the 2 out from the 42, so the 42 stays the same. So if I pull a 2 out from these first two terms, the 2x squared plus 20x, when we pull a 2 out from 2x squared, we're just left with x squared. And when we factor out a 2 from 20x, we're left with 10x. So that's what we get from pulling the a out from the two terms containing x. The next step asks us to complete the square within the parentheses. Now, completing the square is a step that requires a very specific calculation. So we need to find a special number to add in that blank. And the special number that we add in that blank is always b over 2 squared. But to find your b, you need to make sure that you are looking at the number in front of x after you factored out a. So in our case here, b is 10. So this is 10 over 2 squared, which is 5 over 2 squared. Oh, excuse me, which is 5 squared, which is 25. So I'm going to add 25 on the inside of the parentheses there. So again, it would be wrong to go back and say, hey, b is 20. That would be wrong. Don't use that b. Use the new b when you're calculating that. So the issue with adding 25 on the inside of the parentheses, however, though, is that changes the problem, right? Because now the problem says, if I were to start expanding this out, now the problem says 2x squared, which is good. I see the 2x squared originally, plus 20x, which is also good. I see that originally. Distribute the 2 to the 25, and I see a plus 50, which is not in there. And then I'll just bring down this plus 42. So the only thing that's problematic is the plus 50. We changed that when we added the 25 on the inside of the parentheses. So to account for that, on the outside of the parentheses, I'm going to subtract 50. Because I've added 50 in here, and so to balance that out, I'm going to subtract 50, which is what it means to remove a negative 25 along with a factor of 2. So now that we have it like that, let's see what was the point of adding in that 25 on the inside of the parentheses. Well, now we should be able to factor all of this stuff right here. So while we're thinking about how to factor that, I'll go ahead and combine the positive 42 and the negative 50 to give me a negative 8 on the outside of the parentheses. In order to factor that, I'm looking for two numbers that multiply to a positive 25 and add up to a positive 10, and both of those numbers are 5. It will always be that number, whatever number it was you took and squared to find what you wanted to add in. So this will be x plus 5, x plus 5, and it will always be the same number. Because when it's the same number, it allows you to write it as 2 times x plus 5 squared minus 8, which is exactly what we want because now we can see that this is vertex form. We can see that this graph went left 5 and down 8 to now see that the vertex is the point -5, -8. So what we're going to do in the next example is we're going to take a quadratic that starts off in standard form, and we're going to find its vertex, find its intercepts, and its axis of symmetry, and we're also going to graph that. So example 4 is going to be very similar to examples 1 and 2, except it's going to be a little bit more work, because in examples 1 and 2, we started off with the quadratic already in vertex form. But in example 4, this is not in vertex form. We have to switch it to vertex form. We need to write it to vertex form. And in order to switch it to vertex form, we're going to have to follow these steps right here that tell us how to complete the square. Because it is completing the square on a quadratic that gets you from standard form to vertex form.